Use of DIHATCH 6000 UV visible spectrophotometer in the determination of organic compounds.
Hello guys, today we are going to talk about UV visible spectroscopy, or you can say that UV visible spectrophotometer. Okay, so this is UV visible spectrophotometer from the Hatch company DR6000. So before going into detail about spectrophotometer, we should also know what is spectroscopy, or what is UV visible light, or what is UV and what is visible. So normally UV visible spectroscopy is nothing but this is an analytical methodology that is used to compute the amount of discrete wavelengths of UV or visible light that are absorbed by or transmitted through a simple comparison to a reference or a blank sample. So the principle behind UV visible spectroscopy is based on the absorption of ultraviolet light or visible light by chemical compounds, which results in the production of a kind of, you can say, discrete spectra or a specific spectra. Okay, so this is based on the interaction between the light, or you can say between light and matter. Okay, now this spectroscopy is based on the absorption of electromagnetic radiation, which is in the UV visible range with the wavelength range of 200 to 400 nanometers, which is called ultraviolet spectroscopy, and also 400 to 800 nanometers, which is called visible. So we have the range that is lying from 200 to 800 nanometers. Okay, within combined it's called UV visible spectroscopy. Now a spectrophotometry is a method. We now know what is spectroscopy and what is the range of UV visible. Okay, so we should also know what is spectrophotometry. So it is a method to measure how much a chemical substance absorbs light by measuring the intensity of light as a beam of light that passes through a sample solution. It passes through a sample solution. The basic principle is that each compound absorbs or transmits light over a certain range of wavelength. Okay, now certain range of wavelength means we have to find out what is the lambda max. Okay, now we have to find out what is the lambda max. So the lambda max is the wavelength at which a substance has its strongest photon absorption. You can say the highest point along the spectrum, that is y-axis. Okay, and this ultraviolet visible spectrum, for this technique we are going to use quartz cuvettes, which is required for the measurement in the ultraviolet range, because the glass and the most plastics, they absorb UV light. Okay, and they create a kind of interference. So for avoiding interference, we have to use quartz cuvettes, which you can see this is the quartz cuvette here. Okay, and normally for talk about the UV visible spectrophotometer that we are going to use, this is our main interface, which is called the whole system is called DR6000, which we have a main menu, we have store programs, we have user programs, we have single wavelength scan, we have barcode. So not only you can make your own calibration in this equipment, and also you can work with Hatch barcoded kits, and you don't need to do anything. Just need to put your kits and it will read the barcodes, and then it will give you a value. Okay, for storing our own programs, we have a section called user program. This is our own program stored. So the first one is for crystal violet EBT, and then this is for other other pollutants. So you can also make your own program and store. Okay, now before doing that, let's talk about single wavelength and wavelength scan. Okay, so today we are going to know about the calibration. We will do the calibration of antibiotic that's called ciprofloxacin, and there are other accessories that are used for high volume testing. Like you can see, this is a carousel. You can take it out and you can store. Okay, normally this is for troubleshooting and checking. Before you switch on the machine, you need sometimes to take out for checking or for some scanning. Okay, so you can take it out, or also you can remove this while cleaning. Okay, or if it goes out of order, you can replace this with a new one. Let's start with the calibration. So we will close this one. So while analysis, you always have to close. While putting, you have to keep, these are different sizes cuvette, for different sizes cuvettes. This is for 10, 20, 30. I already discussed. You can go from 100 to 100 nanometers cuvettes. Okay, now what we will do, we'll go to the wavelength scan, and then we have to specify which wavelength you want to work. So in my case, I have put this to 200 to 500 nanometers. Normally the maximum wavelength of ciprofloxacin lies from, I told you earlier, it will be 250 to 350. It depends, okay, the purity of your pollutant, or the purity of your water also in which you are preparing. So this one you can see is my ciprofloxacin. This concentration is around 35 ppm. So the solubility of ciprofloxacin is around 35 milligrams per liter in the water. What I have to do, I have to put my cuvette here and also make sure there is no impurities at the edges or on the surface. So what I have to do, this arrow should be pointed here. I'll put here, and then first of all I have to zero it, and there should be nothing. This is deionized water, so I will say 0. So yeah, now you can see there is a straight line coming up. Since this is a distilled water, so there would be no peaks. So now we will put our pollutant and we will see what is the lambda max. So you can see here, this is our lambda max, okay, for ciprofloxacin. Okay, so this is around 320. So this absorbance is 1.433 and the lambda max is 320 nanometers, which is, I mean, like acquired from the lambda max spectrum from the UV visible spectrophotometer. Task would be, we have to come out of this window. Now we have to go to the user program, and we have to go to the, okay, now what we will do, we'll go to program option, and then we will say new, go to the new, and then we will say okay, and then we will type our name. So our name, I'm putting this here, C, then I'm adding I, okay, making a short form for ciprofloxacin, CIF. Okay, then I will press next, and then it says single wavelength multi, so I will say single. I'll choose single, and then I will say I want, so I'll say milligram per liter, and then I have to specify the wavelength. So for the wavelength was, you, if you remember, it was 320 nanometers. So I'll press 320. This is very important to mention the wavelength. And then I'll say, and then what resolution you want. 0.01, 0.0. Let's go choose 0.001, and then I'll go here, and then we have to mention the chemical form. So we will say here, okay, CIF, short form. Okay, so next, and then we will press read standards and next. Okay, now we have to add which standards we want to say. So first of all, you have to make 0, and then we will say 0.5, and then we will say 1. Okay, and then we can add 2, and then we can add 5. Similarly, we can add 10, and then we can add 20, and then we can add as much as point. So the minimum number of point, I hope you all know, that should be, for a calibration fit, should be at least 3. Okay, so we'll start from 0, and first of all we have to prepare these standard ranges. What we will do, first of all, we have to zero it. So for zeroing it, we have added deionized water, and then I'm gonna press 0. So it's already 0, so I will say read. Okay, now I have to add to this one 0.5 ppm of ciprofloxacin. So what I will do, I have already prepared this. Now what I will do, I will transfer this here. Okay, okay, now make sure there is no thumb impression and there is no dirt on the cuvette. This is our quartz cuvette, I already discussed. Okay, why do we use quartz cuvette and why we don't use glass one. So I'll press read. So this absorbance is around 0.024. Similarly, I will throw this and then I will add okay. Now I will add this one. First of all, I will rinse this. So after cleaning this, so I will add this cuvette here, and then if 0.5 is rating 0.024, so one has to be double. Absorbance should be double. So I'll press it's not double, but it's more than. So we will check what's the issue. Let us do one by one. Now we'll add 5 ppm. Okay, this is our 5 ppm. So it's the 5 ppm, sorry, 2 ppm is, I mean, like, it's okay. So you can see this absorbance here. We'll check again the absorbance of 1 ppm. We'll press here. So it's almost double. And let us check again the concentration of 2 ppm. Okay, so it's okay, showing 0.058. Now we will check the concentration absorbance of 5 ppm. Okay, so it's almost showing 5 times than, I mean, like, if you see 1 ppm is 0.047, so it's almost 5 times. Okay, now we will check the absorbance of 10 ppm. So 10 ppm, you can see it's almost double of 5 ppm. Okay, it's 20 ppm. So it's also more than 10 ppm, so it's almost double. Now we will take the absorbance of 30 ppm, so it's almost more than the 20 ppm. Now we will check the calibration. So you can see the calibration is 0.995, so 0.995, so it's almost equal to 1. So our calibration is okay. So we'll store this and we can store. Okay, now it's stored. Now we have to come out of this window, and you can see this is stored here. So for measurement, it says start, and then what we have to do, we can use this as unknown, and then we can check our, so we'll press 0. So it's 0, and then we're gonna check that 30 or what. So it's almost equal to 30. So our calibration is perfectly okay. So I hope you all like the whole discussion. It was a bit long. Okay, so I hope you all like and understood the calibration. So normally, if you want to see your reading in absorbance and transmittance, so you can change, and then it can see, you can see all the readings. So it's absorbance, transmittance, all. So you can just change. Click on the option, you can just change here. So you can see this is our, come out of here. So it's
subscribe
29.321 ciprofloxacin as in a known sample. Okay.